Um, hmm. Can people hear me talking right now? Um, I see yes, but maybe that was the answer to. Oh, shoot. um, I don't know if I can get the camera to work. Okay, looks like people can't hear me talking. So there might be a delay. Okay, perfect, perfect. I don't know why, but my stupid webcam is not even turning on, and it kind of did it automatically last time, so you might just have to deal with not seeing me, which is perfectly fine by me, and I'm sure also perfectly fine with all of you. um, okay, so let me bring up the thing. So let me bring this guy up over here. Um, okay, looks like everything's working. So, hey everybody. Oh, it looks like there's a delay. Let me bring up a timer just so I can see where we're at. Sorry, I have a bunch of windows open. So I don't know why, but my webcam is not turning on. So you'll just have to deal with the slides. Sorry. And obviously I'll be streaming the notebooks as well. Um, okay, so in general, I believe there is a bit of a delay from what I'm recording slash showing you versus what you see on the screen. So keep in mind you may need to basically go back in the live stream, and I may ask you. The chat is instant, but the video is not. Okay. Um, do we have any questions so far? I can wait. Like the thing is, the questions are gonna be like a little delayed. But does anyone have any questions in the chat? Let me type that out. Any questions so far? So far on data link? Let's okay. Let's see if we can get this to work. I'll try one more time with the webcam. If not, I'm giving up. All right, I give up on this stupid webcam. All right, perfect. All right, now I'm getting some questions. Good, looks like everything's working. Okay, so as far as modeling, machine learning stuff, not really. We're really focusing on data visualization and pandas, and we're going to use some new libraries that are actually probably not going to be a permanent part of the course just because they're more specialized and they tend to also change and update a lot, so it's really annoying to have them as part of the course. So what we're going to be working with is Plotly, Folium, and Cufflinks. Cufflinks is kind of optional. It's just a way to make your stuff interactive. So if your environment activated, you'll need to install these with pip install. Um, technically, Plotly and Cufflinks, you don't technically need those. You could just have static plots, but I think for this, it really helps to have them interactive. Folium is just a geographical plotting library. So, as I mentioned, this is probably not going to be part of the course officially, these three specific libraries, just because they're kind of a headache to keep updated. They change, specifically Plotly is the one that like changes all the time. But maybe we have this kind of like an appendix where we just say this was filmed in late 2020. It is what it is. I'm not sure. Well, bad phrasing to use with COVID-19. But Okay, so what are the goals here? I'll after you've installed Plotly, Folium, Cufflinks, let me know if you have any issues with that. But our goals really are to kind of learn how to clean and read data in pandas. For the most part, the data is already pretty clean. It's not like it's missing stuff. We just need to play around with it. We're also going to explore possibilities of Folium plotting library, and we'll play around with some of the parameters you can do. It's mostly, as far as like Folium goes, you basically just look up in the documentation the plot type you want, and then you copy and paste it, and then just fill in with your data. So it's kind of like a plug and play thing. And then we'll explore cufflinks, pandas, and Plotly for interactive plots. It's essentially the same as plotting with pandas, where you just say, here's my DataFrame.plot, except it's going to make it interactive just kind of instantly, hopefully. We'll see if anybody has any issues with that. Sometimes browsers can kind of try to fight it. And something you may be hearing me say quite a bit is, does anybody have any questions? Just because this feels more interactive. I don't know. It feels less interactive without the camera. So we'll see how it goes. All right. So download link is in the chat. In case you haven't seen it yet, just scroll up. It should be there. Someone has a quick question. Can you make these streams like assignments? We could work. Possibly. We'll see. That's a good thing or good point. I'll look into that, seeing if I can get it out in time. The thing is, we are also filming the rest of the course as we kind of go along, so I'll see if I have enough time to do that, but it's a good idea. Okie dokie, artichoke. So here's my notebook, and where my notebook is located, you should have the Storytelling COVID-19 notebook, and you should have a bunch of CSV files. Not all of these are we going to use. Also, not all of these are fully up to date to today. Okay. Sorry, you may be hearing me drink some water from time to time. All right, so just in case it's not clear, there is going to be a delay between you asking a question and me hearing the answer. And from my experience last week, the delay gets worse and worse as time goes on. And the issue with the delay is, like, right now it's going to start at like a 30-second delay, but by the end of the stream, I'm like 15 minutes behind what you guys are, or ahead of what you guys are watching. So just keep that in mind. From time to time, you may see me bring in this little stopwatch marker just so I can tell where you guys are compared to me. Okie dokes. So let's do some freaking imports. How's that size? And what we're going to do here is just import the libraries we're already set up with. And just if there's a question that needs to be answered kind of instantaneously, just put it in the chat and I can chat instantaneously with you. So import numpy as MP, import pandas as PD, and let's go ahead and import Seaborn just in case we need it. And also import matplotlib.pyplot as PLT. And then you should also be able to import Folium if you installed it correctly. And then go ahead and let me know in the chat if you had any issues installing Folium. No, Patricia, Plotly and Cufflinks are not part of your base environment, so you need to install them with pip install. So again, it's just pip install Plotly, pip install Folium, pip install Cufflinks. Kind of optional, but I would recommend it for this particular case. And you can just run that at your command line, or you can also do it from the drop-down in Anaconda Navigator, I believe. Okay. So what we're going to do is read in some data sets here. We have a lot of data sets, and we're also going to be doing some renaming stuff just to make it a little easier to use. So go ahead and say df is equal to pd read CSV, and we're going to read the file called covid19data.csv. And what's really nice about pandas, if you've gone through the time series section in pandas, it reports back to you, or we talk about the fact that it can actually parse dates automatically for you. And you can say parse dates and this can be either equal to true, which is just, hey, any dates that are in the CSV file, go ahead and try to parse them, or you can actually make this a list of specific columns to look for. So you can say, okay, I want you to parse dates. Specifically, there's a column called last update that I want you to parse. And you may be experiencing some buffering issues right now, but you can just kind of scroll back in time through the video to let it encode. So go ahead and run this, and then you should see a data frame that looks like this. Excuse me. So this looks a lot like pretty much any COVID data set you'll find on the internet. Will say some sort of date or last update. It may go to province or state, or may just be country region, and then it will say confirm, deaths, recovered. This is basically almost always the three categories. I would say just kind of type along as far as type along with me if you want. Up to you. Okay. So what we're going to do is we are going to take a look at some of this data. Let me, bring it in. Sorry, I'm trying to zoom in on the other country. Okay, so any questions so far? I know this is kind of going to be, well, okay. Looks like everything's good. So what we're going to do is kind of just clean up this file. I got it from Kaggle. Kaggle has a bunch of coronavirus data sets that are being kind of updated from time to time. I don't think this one's updated all the way. I think it ends in like May of 2020. So essentially, what I would like is something that can be grouped by country. And sometimes some countries have this issue of a white space. So that's what we're going to be doing. Yes, the parse date option. Okay, so let's go ahead and check this out. Whoops, gonna zoom out just a little bit to make sure we're on track. So one of my goals here is to check out the, let's say, top 10 countries with most confirmed cases at the time of this data set. And we'll try our best to link you to a more updated data set than this one. I'll try to get the background source of the CSV files, because some people are uploading CSV files, but they're not updating them on Kaggle. So this one's based on just some Kaggle link. I think Kaggle, if you just Google search coronavirus on it, it has kind of the official one, but it's not up to date. Johns Hopkins is really the place to go for it, which I think is where all these are eventually coming from. Okay. Looks like the stream is actually not so delayed, hopefully, given the responses here. Okay, so what would be nice is if we can get a data frame for top 10 countries with most confirmed cases, and then maybe try to do a world map, either with Folium or Plotly. So that's kind of what we're going to do. We're not going to do all of these, just because if we try to go through every single section here, it's last update, not last updated. So let's clean this up and try to see if we can do some nice plotting here, or just some nice data analysis. So what I would like to do is also read in another data frame, or kind of set up a data frame. So let's rename some of these. I don't like that it says province, state, and country/region. Let's just rename those. So we'll say DF, and there's many ways we can do this sort of renaming and cleaning process, but we could say df.rename. And one way to do this is if you want to rename just a single column, you say columns is equal to, and then this dictionary, and you pass in, hey, I don't want country region, so you give that as the, it's almost like a map call, and you say country region, colon, country. And then we'll say in place is equal to true. So now if you run this, you should be able to see df head and that column has been renamed. There's a quick question: timestamp different than datetime object? It depends on what you mean by that. There's both a time object in Python, which is just holding hours, minutes, seconds, etc. Then datetime also holds the date. So this is essentially just time, and this is date time. Timestamp is just kind of a general term I'm using. You can also just check the data type by saying df info, and then see that it's a datetime object. So when I say timestamp, I'm just speaking generally timestamp. Okay. So here's the data frame, right? We have this last update. We may even just want to change observation date into a date timestamp, depending on what we're trying to do here. And let's go ahead and essentially drop these two columns, SNO observation date, because I don't really need them since I have last update. And this is just a serial number, right? You can see that it's just an index itself. So let's say df is equal to df.drop. And the columns I'm going to drop are S and O. Whoops, that should be capital N. And then also observation date. Notice that I pass this in as a list. And these are columns, so I have to say x is equal to 1. And hopefully by the time you're watching this, you're a little bit familiar with pandas. This lecture in general will be a lot to take in if you've never worked with pandas before, so keep that in mind. You may just want to then just kind of sit back and treat this as a TV show and then something to follow along with. Okay, so our thing is looking better and better, right? We can go ahead and probably keep province and state. Try installing in Anaconda prompt. So when we get to Folium, I'll take a little bit of time to talk about how to install it. But right now we're kind of on track to get a nice data frame. So I have this data frame here, df head. It's looking pretty nice. Some province or state, the country, last update, confirmed deaths, and then recovered. Probably what I would like to explore is a group by operation that would begin to describe this based off the countries themselves, right? So what I could do is start setting up a data frame based off the country. So what I first want to do, just for the sake of plotting this later on, is remove the white space between countries of 2 or more words in their name. So what I will say is df country is equal to df country. And again, this is just cleaning data for later on. And we can say strip. And this will strip white spaces. So this will remove white space. So now when I see the head of my data frame, I can see the white spaces. So you might be thinking, is it this white space? It's actually, it has to do with the white space ahead of a, how should I explain this? Ahead of a column, or ahead of a string, essentially. So if you have a string that says like hello like this, so I kind of didn't explain it correctly earlier. It's not a white space here. It's more of a white space like in front or behind it. So it would change it to something that looks like hello. So that's essentially what the strip command does. Okay, so let's check if we have any missing data. We're going to say df is null dot sum. So it looks like for province state, we are missing a lot of data, which kind of makes sense because not every country is going to have detailed all the way down to the state. It might just say, hey, this is information for just the country level, and we don't have information on the state that it happens to be in, or maybe a specific country doesn't even bother separating stuff out by state. So let me, sorry, my other screen's going a little crazy right now. Okay. So what we're going to do is if we are missing the province state, I'm just going to replace it with the country. So if it just says something like Spain with no province in it, we'll say, okay, label the province or state as Spain. So there's many different ways we could do this, but what we can do is the following. We can say df where province state is null. And then what I'm going to do, so again, this is going to be a true and false series. And then we're going to say the following. I'm going to say df LOC. And then we're going to say df province state is null. And essentially what I want to do is eventually replace this with the, oops, oh, crap. Sorry, I'm trying to scroll over, but it's not letting me. I have to capture this perfectly. Sorry, I'm going to copy and paste some code here real quick. So essentially what I want to do is replace it with country, and this is one way we can try it out. So what this does is going to locate all the index locations where is null, and then we can talk about province state, and then after that, go ahead and replace it with country. So we'll say, comma, and we have to make sure we spell this exactly correctly, province/state. So if you run this, it'll give you just a bunch of nulls for wherever we're missing the province state. So notice how it starts on 35. So if we say df head, let's get like 40. You'll notice some of these are missing, right? So Japan is not separated into provinces here. So we can see there's a null there. And essentially what I want to do is set this to Japan, set this one to Thailand, set this one to South Korea, etc. So then I can do that by saying equals to, and then we're going to grab this guy, kind of put it up again. But now what I want to do is essentially set it equal to this thing. So this is df ILOC, province state is null, and then the country. So notice now this is essentially saying grab the index locations where this is null and give me back the country column. It's almost like very similar to NumPy, the fact that I'm using a comma here inside .loc. And we can think of .loc as just a general location mechanism where it's kind of doing, hey, rows or some sort of condition on the rows, and then column or some sort of condition on the columns. So that's kind of the format it's following. It says, hey, grab these index rows and then grab this columns. And in theory, I could also pass in a list of columns here, but I'm just interested in country. So all I'm saying is where all of these are null, go ahead and fill it in with the country column. Lots of different ways you can do this, but this is kind of the, I would say, the slickest way possibly. So then we're going to say equals here. This is kind of a long line to show. That's why I was having trouble kind of typing in earlier. Let's see where you guys are. I'm going to bring in the stopwatch I have, just so I can make a little marker for myself when I see the stream. So I'm at 21 minutes-ish. Okay. So we'll continue on. Let's go ahead and run this cell. Check the DF head. And maybe in future streams we don't have that much data cleaning, so we can just get to the cool stuff. But it looks like nothing too crazy went. And let's go ahead and do up to 40. And perfect. Now we have Japan, Thailand, South Korea. It's all looking good. So we were able to start cleaning this up. And then what I'm going to do here is begin to create a kind of DF country. So let's do the following. Let's say DF country. Paste what line? Oh, I think you mean this line. Let's see where you're at. There we go. Okay, so let's try this out. We're going to say df country is equal to, and I'm going to say df group by the country column. So we'll say group by country. And let's go ahead and just take the sum. So we run that, and we should see something that looks like this. df country. And now I can see some countries, it looks like they're slightly messed up from our kind of best efforts to fix them. So this is one of those, I believe it's one of those islands that has a really long name. But what's really interesting is it also separates out Israel from occupied Palestinian territory. And then we have essentially the three columns that I really wanted to know about: confirm, deaths, and recovered. So maybe what we can do here is begin to explore this. based off the populations of the countries themselves. In which case, I need to actually get information of the population of the countries. So how can I do that? Well, we do have another CSV file for us in order to explore that further. If we take a look at this, essentially the zip file, there was a countries by population 2019.csv as well as country codes 2020, which would be useful later on when we're actually plotting this stuff on a map. But if we say countries by population 2019.csv, I'm going to see if Jupyter can display it. But essentially what we have here is the population column for each of these countries, which is something that's going to be obviously really useful if I want to get cases per million or something, right? Because we don't know, if I don't know these countries themselves, I actually don't know if it's a big deal for some of these countries to have this many cases, right? When we want to accurately compare one country to the other, it's going to make a big difference if there's over 1 billion people in India versus however many millions live in Canada, right? It's going to be a difference on confirmed deaths and recovered. So really what we're looking for here is a ratio for these countries. So let's go ahead and read in that data set. I'm going to read it in now. Let's say the following. DF, I'm almost tempted to keep a little stopwatch here that I continue to go back and forth. Okay, let me check again it's countries by population CSV. So countries, so what I'm going to say is countries is equal to PD read CSV, and let's read in countries by population 2019, and let's also, that's double quotes. And I'm just going to say, due to delay, best way to interact with me is chat. Okay, so we have countries population 2019.csv, and then I'm also going to say countries underscore ISO is equal to pd.readcsv, country codes 2020 CSV. So countries ISO, if we take a look at that, it's just the actual different ways we can. It's essentially a code, right? An international code for each of these countries. There's, depending on what system you're using, I think it's a USA versus a European system. One is 2-letter codes, and then one is 3-letter codes. And then apparently there's also some official numbering for all the countries in the world, which I was not aware of before running this project. Okay, so now the question is, how the heck are we going to combine these in order to get everything lined up together? So what I'm going to say here is I'm going to merge them. So I'm going to say the following. Let's say countries. So recall this is countries column, or countries data frame, has the full name, population, growth rates, etc. Really what I just care about is this 2019 population and the name of the column. So I will say countries is equal to countries, and I'm going to merge it with the ISO. So I'm going to say countries ISO, and we'll say, name and CCA3. In theory, I could merge it with the entire country's ISO data frame, but I don't care about having every single thing that wasn't country's ISO. If we take a look at it, there was kind of a lot here. And really, I just want maybe the name, and let's go with CCA3. I don't care about the 2-letter code and the 3-letter code. So I'm just I'm really just merging it with a kind of a half a data frame, if you will. So that's what this is doing here. It's just merging it with those kind of subset of the data frame. And then we have to decide what are we going to merge it on. Obviously, the most obvious is name. So China here should be merged with China in this data frame. So then we're going to say on name. Hopefully this feels very similar to SQL if you're already familiar with it. So then what we're going to do is we're going to say how is equal to, and I'm going to say how is equal to left. So what does that actually mean? It means only keep countries that are in this country's data frame. So if we get some sort of weird country, like, I don't know, Wallace and Futuna, or whatever country this is, if this particular country is not in my main country's data frame, then I'm not going to consider it. Because if we look at our main country's data frame, it only has 222 rows, right? However, this one has 231. So I'm just going to consider it based off the one with less. What we could also do is do this kind of as an inner merge. But we'll go ahead and say left for now. And whoops, CCA, CCA3, CCA3, name. What was it complaining about? Oh, this should be a list of lists. There we go. I forgot an extra set of brackets because I should be passing in a list there. Run that. Okay, perfect. So in case you were wondering what it was complaining about, when you pass in multiple columns, you have to pass it in as a list. So that's why you need the 2 brackets there. Okay. Let's see where you guys are. Oh, you're actually not that far behind me. You're only like 30 seconds. Last time the delay was really bad, so this is actually way better than last time. I think it's because I was trying to stream the webcam last time as well. So maybe this is actually beneficial for us that you're not seeing my face. I'm sure everyone agrees. Okay, dokie. So we have this really nice countries data frame. It has some stuff that I don't care about, like rank and population in 2018, and also growth rate. So what I'm going to start doing is removing some of these columns that I really don't care about. So what I will also do is start removing this more information on this. So let's go ahead and say the following. Countries is equal to countries. And the columns I really care about are name and population 2019. And let's go ahead and also grab the 3-letter code here, CCA3. And I don't think it's going to be interesting to check it out as like infections per total square area of country landmass. Maybe that's interesting to you. I think on a country level it's not very useful, but if you're considering something like a city area, that would be interesting. But for our use case, it's probably not very useful. Density would possibly be interesting because that's going to be population per area. It might be interesting to see if there's a relationship between how many infections you have per country versus the density of the country. But we'll go ahead and just keep countries. We can always come back to this and add in more columns that we're interested in. So now I have countries here, the name, population, and then I also have DF country. And recall, DF country is kind of the one with the information. Okay. Mainly, let's keep the chat to questions, not affirmations. Okie dokie. So the main goal now is to somehow combine DF country with this country codes that has the population, and then there's a ton of statistics we can get there, like confirmed per million, deaths per million, and recovered per million. So let's go ahead and do the following. Let's just first remove any countries that we don't have any information for. So I'm going to say DF country. Well, actually, we want to merge this first. So we'll say DF country is equal to, and we can say, there's kind of 2 ways of doing this. You can say PD merge and then pass in the data frames, or you can just call merge off the data frame itself. So we can say DF country merge, and I'm going to merge this on countries on the country column. And if I'm actually going to do this on the column, this is an index. So we'll say, if we check this out, it should be left index is equal to. So we'll say left index is equal to country. Hopefully I'm doing this right. I'm kind of editing this on the fly. And then we'll say how is equal to left. So we're kind of almost having a structure of more important data frames, right? We were saying that this country's data frame was more important than country's ISO as far as like what information to keep. And now I'm definitely saying, since I'm calculating confirmed, deaths, and recovered, the most important data frame is stuff I actually have information for. So we're only going to say, only consider left. It's not going to be useful to me as far as like plotting our information if I have information about this niche country's like population, but I have no information about their actual cases. Okay, so merging this together, let's pray that I hopefully did this correctly. Left index parameter must be of type Boolean. Oh, that's correct. So we'll say left index is true, which means I need to say on. On should be, oh, here we go, right on. Right on should be country. So let me explain this because it can be a little weird and tricky, left index versus right on. there's essentially a couple of options here when you're joining data frames together. There's the ability to join on index or join on a column. So for these particular cases, there's the left data frame and the right data frame, right? The left data frame is this first one, DF country. The right data frame is the second one, countries. This kind of goes along with SQL joins. So if you're going to join on an index, you can specify the left index and the right index. So what do you want to join on the left index? What do you want to join on the right index? Or if you are going to join based off column, you can say left on or right on. So essentially you can say left index, right on, left index, left on, or right index, left on, etc. Okay. As far as how many live streams, it's going to be until the end of the year, possibly. I have no idea. Until the course is finished, let's put it that way. Left index is a boolean in documentation. Yeah, I think someone just caught me on that. And now you see me explaining this. Sorry, I didn't see the chat. Okay, I think we did this correctly now. It makes sense that index is a boolean because you only have one index, right? So let's run this again. Key error country, you're seeing me do bugs. Good thing, I guess, right on country. What is it actually called? It's called name. Boom. All right, so now we're getting somewhere. And what actually might be easier is if we drop NA here. So I'm going to say DF, drop NA, and we'll say DF country is equal to DF country drop NA. And now we're starting to get somewhere. So what do I have so far? I have this index position, which is now kind of meaningless. It's essentially the index position of the original DF country, but that just had to do with the name itself. But I should have the confirm, deaths, and recovered along with the population. And I hope I merged this correctly, because, or maybe there's just not good data for Afghanistan, because some of these don't make sense to me. As far as population. Oh, I think this is population in millions. Obviously, 43,000 people don't live in Algeria. There's going to be more. It should be in thousands. In which case, I hope this is going to be correct. Let's do a little bit of math in our head. Is it reasonable that we have 3.5 million cases in Algeria with a country population of 43 million? Yeah, I think that's reasonable. What about this? Yeah, that also seems reasonable to me. Okay, how are you guys doing in the chat? Everybody good? Any questions so far? Any questions so far? Next step is to calculate stats for each country based on pop. Okay, so we have this really nice data frame. All we need to do now is start getting some sampling from it, or stats from it, I should say. So let's say the following. I'm going to create a population columns in million. So I'm going to say df population in millions. And I'm going to base it off this pop 2019 column. That way I don't also confuse myself by saying, like, how's it possible there's so many confirmed cases with such a small population? But this is technically in thousands, right? So it's just going to be DF country, and it's going to be pop 2019, lowercase, pop 2019 divided by 1,000. So again, this is in units of 1,000. So let's go ahead. Yeah, and this does seem a little high to me as far as deaths, but I'm not completely up to date on each country. We'll have to see. We'll have to see if United States lines up, because that's the one I'm most familiar with. There's possibility that some of these are not reported well for certain countries. Because I do agree, some of these countries look a little suspicious as far as these numbers being so high for some of these. But we'll see. 128,000. Yeah, that's a lot. We can do a quick Google search. Afghanistan COVID deaths. Yeah, I would agree. It looks like this number's off because from what I see in this Google search, so clearly some of this data is not super great. Um, but I can see here in Afghanistan, yeah, it should be something like 1562. And I'm not sure what the units are here for these defs that we need to fix if it's not so high. So we'll have to check that out if we need to adjust this column. It's possible that these defs are incorrect or units different than us. Okay, and if not, I do believe I have kind of fixed versions of these data frames if I fix this. Okay, let's try this out. And I also want to round this off. So we're going to say round np.round to 2 places. And again, don't worry about this warning. It's just telling you you're working with a copy of a data frame. So let's see DF country. All right, we're starting to get there. Population in millions. Does this make sense at least? Let's just Google search the population of Afghanistan. Population of Afghanistan. It looks like somebody is 37.17 million, and this is telling me 38. Okay, that's reasonably close. Still, giant question mark of these numbers, right? We might have to kind of put a big question mark on these because I'm not sure what's actually happening there as far as the cases. Let me see. Did I remove these or something? I don't remember having this issue earlier with one of these countries being so far off. And I'm curious if possibly it got joined with the wrong, since I did it by index, if it got joined the wrong way. Let me check out the original. Index 36. Was that Afghanistan to begin with? Countries, is it still the original countries? What is ILC 36? It is Afghanistan. What about the other one? Where we had, what was the original one we called? Was it DF country? Oh, but that's the one we've been messing around with. Oh, here we go. Let's say DF. DF. We'll see how bad it gets. It's a possibility that we did not join these correctly based off index, that it merged them incorrectly. And I kind of want to confirm that before we continue on here. Let's see, DF head. Maybe somebody, yeah. No, Kingbach, I think we joined the countries incorrectly. I think what happened was it's like taking China's and putting it to Afghanistan just because it was in the wrong order. So what I'm going to do is quickly fix this by, instead of joining based off the index, I think that was the issue, that it didn't do the index correctly. Well, not that it didn't do it, I messed it up. Because I don't remember getting something this crazy before. And I'm almost positive these are another country's numbers. So, because I think it's because I said it based off left instead of based off, because this is impossible that there's this many deaths. Okie dokes, let's try this. Let me quickly review my notes because we've been kind of skipping along here. Very true, but I believe it's a little hard because these CSV files come from different sources, so that one can be calling it mainland China, one can be calling it China. Good observations here. It's always good to make sure that we don't continue with something crazy. DF countries. Let's quickly see where we left off, or let's go from the top and see everything that it's making sense. So we read in, read in COVID-19 data. Yeah, hopefully this is kind of a realistic depiction of what actually happens when you're dealing with data. Province, state, country, right? Okay. Last update, confirmed defs. That all looks good. I'm going to remove any white space for in the future. And here I have country, mainland China. What we can do is relabel this China. So let's just go ahead and do that. I think that might have been the issue. Let's say, um, well, yeah, I think we have to rename some countries here. That's the issue. So I see. Yes, correct. Okay, it's forgot to rename some countries. Skip that step in the notebook. Sorry. Okay, there are countries we need to rename here. That's part of the error of what's going on. Plus, the index is the other issue. I believe we accidentally assigned all of China's mortalities to Afghanistan just because China was first in one data frame and another. So let's do this. I have a dictionary in the actual notebook, which are some important mismatches. Yeah. So China is obviously one of the most important considerations we have to make if we're doing anything based on COVID, right? So I can't just drop it off, but I do need to rename it. And United States is also one that I need to rename. So if we check out our data frame right now, I have mainland China. And if you see, there's in the notebook, there is a dictionary called countries to rename that looks like this, where it changes US to United States, mainland China, China, and we kind of completely forgot to run this line, which affects everything down the road. So sorry about that. Okay, so now I have countries to rename, and let's go ahead and do this. We're gonna say countries, and let's see here. The question is, do we rename? Yes, so we're gonna say the following. DF country, rename. Worst case, we just copy and paste a cell in the lecture notebook to all of this. Okay, DF country, rename. And then we're going to say columns is equal to calls to rename. Whoops, actually no. DF country, country is equal to DF country, country. And is it already called country? Yes, it is. Okay, good. This should actually just be DF. Oh, yes. DF country, and then we'll say replace countries to rename. All right, sorry about any confusion. So this was one part that was screwing us up. The countries were labeled differently, so when you join them, you're losing a bunch of information. And because you told them to keep the index, it wasn't working. It was essentially kind of assigning things based off their location. There we go. Okay, let's check out the data frame. Province, country, perfect. And now what I need to check is if that, recall that we fixed the issue of missing a province or state. So let's check that out as well. And that was this line. So let's rerun this line. Cool. So now this is looking a lot better. Okie dokes. And now let's redefine DF country. So I'm going to kind of repeat a lot of the work we just did. Just a few lines of code, actually. So I'm going to say DF country is now equal to DF. Recall DF is this larger original DF that we've been working with. And I'm going to say DF group by the country column. So there's the country column, and I'm going to say give me the sum of everything. So now I say DF country. Run that. Okay, is this still looking correct? Call me crazy, but this still looks too high for Afghanistan, right? But after this, I don't think there's anything we can do. And maybe it is just an issue with Afghanistan being completely wrong. Let's check how bad it is in China. Oh, whoops. I'm going to reset the index. DF country. And now let's check where country is equal to China. Where DF country is equal to China. Equals. Well, this number makes sense. Why is Afghanistan so weird here? It could just be bad data or something. Maybe it was reported by like per 1,000 or something, right? I agree with the other people here. I think Afghanistan just fundamentally messed up. It may not have been our fault. It's just the data is bad. If I take a look at the original data frame, let's check it out where it's equal to Afghanistan. There might be something we need to clean up here. Where DF country is equal to Afghanistan. Maybe there's one row or something that's really bad. Yeah, there it is. Like, what the heck? This doesn't seem so crazy, but still. September 20th, and I'm looking at the COVID. What are your thoughts, students? Afghanistan weird or not weird? Thoughts on Afghanistan? You're probably seeing this on me right now. This looks incorrect, right? Because this is 1,400 people. That doesn't make any sense. These are like United States level numbers here. Yeah, I agree. Not sure we can fix this. Something is up here. Oh. Okay, yeah. That's right. Okay, that makes way more sense. It's an accumulation. Holy crap, that was confusing. That's right. Oh man, that was yes, we do need to take the most recent date. I was so confused there by taking the sum. Okay. Let's fix that. We can fix this on the group by call, which I think I may have missed completely from the notes. Let me look this up real quick on the notebook. There, as index false, confirmed defs. Sum. One second. I'm just looking to make sure my notes here were correct. Yes. Where did we grab the observation date? The observation date. Drop duplicates. Ah, I see what we did. Okay, I missed a huge step. I'm so sorry. See, I'm trying to follow along, but I put everything in one cell, which was a mistake because here I'm trying to type along with everything. So we missed, I hope you can see this now. I missed a really big line, which was the drop duplicates line, doi. So this drop duplicates line would take care of this accumulation issue, right? And maybe you can tell me in the chat if you are hearing me mess this up. It looks like we're still talking about it. We forgot to drop dupes. That will fix this issue. Okie dokes. So we first need to sort it and then drop it. So what we're going to do here is we are going to sort based off the date, and then we're going to drop the dupes, and that should fix all the issues we had earlier. Okay, I was going crazy here trying to think or remember what we did. We're actually going to true, but we will sort first before. Okie dokie artichoke. So I'm going to copy and paste these lines from the notebook just to make sure I don't F this up anymore. Okay, these are two very critical lines that I completely forgot. And it is the sorting of values, and we're going to do it by ascending. And you can actually ascend them based off individual columns. So I can say sort by country, then sort by province, sort by observation. That's true. It makes you at least it shows that you're not going to blindly. So in reply to Patricia's comment, at least it shows that I'm not just blindly following along, right? I think we all kind of scratched our heads once we saw Afghanistan being crazy, and we're like, what the heck happened here? So that's definitely good to keep reality checks like that. Otherwise, you know, file this report and you show that more people died in Afghanistan than exists in Afghanistan. They'll be like, what the heck just happened? Okay. So that's right. And I remember thinking like, oh, this is a cool thing to show them that we can ascend by different values on multiple columns. So let's try this again. I think we accidentally already deleted this, however. So I'm not even going to keep observation. I'm going to keep last update here. That's right. That's right. Okay. So let's rework some of this. I will keep these columns, but we dropped some stuff before we should have. Where did we drop it? These guys. We'll drop these later because we actually still need them. Hello, Anthony. So I'm going to rerun some cells here. Okay, I'm going to keep observation date, last update. This is all looking good. And then what I'm also going to do is make sure parse dates, last update. I think I accidentally Sorry, I just want to make sure I don't make another mistake like this and have to rework this whole thing again. Let me see what happens if I just sort the values right now. Damn. All right, we gotta. I'm not sure if there's too much work we can salvage from before without getting another mess up further down the line. So I want to make sure I can still do this. Okay. Gotcha. All right. Hopefully that made sense to everybody as far as the issue we did was that we're not looking at the accumulation. We were sorting by the wrong thing here. So what I'm going to do is, so I have this sorted version of the data frame now. So then what I can do is drop the duplicates. So let's go ahead and do that. We're going to say df is equal to df drop duplicates. Intro to coding. Anthony, that's probably a better question for the Discord channel. Unless you're talking about one of our courses problems, but I don't quite remember that. Df drop duplicates. Country. And also then province states. And then I'm going to say keep first. And before I do this, I want to do the fill-in of the missing line that we did earlier. Because right now I have nulls for province, so let's go ahead and just make them duplicate in case the null affects us as well. All right, so in case you're kind of confused of what the heck I just did this past like 10 minutes trying to fix this error, these are cumulative. So what I want to do is sort them based off the dates. And then I also want to fill in the issue that we talked about, province state versus a missing country. And then I'm also going to then just keep the first after I sort them. So let's run this again. See this, make sure, pray to God this all works. Let's say DF, Afghanistan. Whew, okay, that's looking much better, right? I think we're almost there, folks. DF country is equal to DF. Let's actually drop, well, let's not drop anything yet. Group by country. And then what we're going to do, so did we even need the group by country? Not really, right? I think at this point, I'm not sure why I had the sum for the group by. Let's try it out anyways. Hopefully this, well, I guess if everything worked well, this shouldn't change anything, right? Not really. How are we looking on Afghanistan? Okay, this is looking good, right? Yeah, but the deaths, that's good info, Patricia. But the deaths didn't make sense what we had, right? We had like half the country dying or more. These deaths make a lot more sense with what I saw here. And I think in general these deaths seem to look good, right? I think everything here is reasonable as far as deaths, and it should match up more or less with what we're seeing online. So let's just choose, let's say, let me reset the index here. So I'm going to say df country is equal to df country reset index. And then once we get this data frame going, we should be able to really quickly like display stuff and plot it. That's looking good. So now I just want to check where country is equal to China. And I can't remember if it's still mainland China or not. So I might have to edit that as well. All right, let's do mainland China. Okay, that looks all right, I think. United States. The United States, what was it called again? Does anyone remember what the correct United States term is? I think it's called United States. Let's see. Is it just, no, it's not just called US, is it? Oh, it is. Does this make sense? I think so, right? That sounds about right for my knowledge of United States. Could we not do it with ETL tool? Not really, because, I mean, it depends what ETL tool you're talking about, but this sort of stuff is pretty specific to pandas. You could easily make the same mistakes. Thanks, guys. So I just want to confirm with everybody before we go on. I think this looks correct, right? Now more or less, DF country is reasonable. So what we want to do is just join based off country to the actual country column we have. So let's just go ahead. I think let's check UK real quick. Make sure that one's also got renamed. Yeah, it looks like everything is kind of lining up for us. Thank goodness. Whew, that was a headache trying to discern what the heck was going on. Okay, so, but that should be a pretty realistic error that you get later on. Okay, let's reread in the population CSV file that we had, and then we should be able to join stuff and quickly go to plotting, especially with Folium, which is quite fun and nice. Okay, so what I'm going to say here is populations. So let's say countries, again, is equal to PD read CSV, and then it's called countries by population 2019 CSV. I thought we did, but actually we haven't. I reran some cells, so we still need to do that. So Here's countries. Let's check out countries now. Okay, so this one is still called United States. So what I'm going to do is now do that mapping on DF country to map these country codes so it matches the name here. And there's more than just the ones here, but these are the most important ones. So I'm going to copy and paste this again from the notes. So again, I have this countries to rename. So this is my grouped by country, and this is the kind of official population. And I need to make sure they match. I can do it one way or the other, right? I could change this United States to US or this US to United States. The way we're going to do it here is we're going to fix, so to speak, DF country instead of countries. So if you run that, then when you look at DF country, you should be able to find United States. So let's check out the tail end of like 50. And there it is, United States and United Kingdom. Perfect. And now we're ready to merge these two guys. Looks like everything's lining up nicely, thank goodness. This is what it should have felt like the first time, but I guess it's nice that not everything's so perfect. Okay, so let's check this out. We're going to say DF country is equal to DF country. And I'm going to merge on countries. And then we'll say on country. And let's base it off DF country so I don't worry about like any weird countries that are in the other one. Did I spell this right? On equals DF country. What is it called here? Oh, name. And here it's called country. Let's quickly rename it in DF country. Countries. We're gonna say, and let's actually rename a lot of these. I'm gonna create a couple columns to rename. Let's say calls to rename. This is what I get for not following my notes too closely. I'm gonna say names goes to country. We're gonna say pop 2019 goes to population. And that's enough for that. There was a question here. What does / mean in a dictionary? Oh, it just means new line or continued line for when you have a really long piece. Actually, I think in general it would work without it. For Jupyter, should work without it. Okay, countries. And now I'm going to rename this. So countries equal countries. Rename columns equal to calls to rename. Let's also pray that this works. Countries. Looking good. Country population. That's looking good, looking good. Merge these guys together. Nice, nice. DF country. All right, we're almost there, guys. Confirm, defs, recovered, and population. Recall this population is in millions. Let's go ahead and only grab the things that I care about as far as columns are concerned. So I only care about the country column. I also want confirmed. I want deaths. I want recovered. And I want population. Run that. Check out DF country now. Here it is. Okay, so it took us a while, but we got there. Deaths and then a population. This is where we kind of should have been earlier. Whew. All right, pretty realistic example of cleaning up your data, which is where you spend like 90% of your actual time. Because all the visualization libraries have gotten so easy to use now. It's like one line of code that takes you like 2 seconds to run. So let's do cases per million, deaths per million. So let's create a new column. I'm going to say cases per million. And let's drop NA because if there's no population, then there's no way we can actually calculate this, right? So we're going to say DF country drop NA. Come back to DF country. Okay, 200 rows, very nice. And now we're going to say DF country is equal to DF country. And I'm going to merge these. We're going to say countries. Whoops, I'm not going to merge shit. Sorry, I'm skipping ahead. DF country. Cases per million. And this is going to be equal to DF. And let's go ahead and say, right now this is in thousands. So if I divide it by 1,000, then it should be in millions. So before we run this, let's do this. Let's say DF country population in millions is equal to, this is where we were, basically this is where we left off last time before I got confused by Afghanistan's issues. 1,000, and now we're going to say, and let's also round this, we're going to say NP, round this to the nearest 0.2 million or whatever. Let's make this into a new cell just so we can be checking our work as we go along. And we get a warning there, but that should be okay, given that it's pointing us. Do about 38 million people live in Afghanistan? I think so. That sounds about right. Perfect. Okay. So we now have this population column. That's looking good. So let's now do cases per million, which is going to be just DF country, cases per million, divided by DF population per million. Population millions. DF country population million, sorry. DF country. That's a good question. You guys can vote on it. Do you want me to edit this or leave the whole thing up? Obviously, it's easier for me to leave the whole thing up and then you can kind of like skip ahead. DF country, and this is going to be cases per million is equal to DF confirmed divided by. All right, does this look okay to people? We have confirmed divided by population, which is actually here. So we have confirmed divided by population in millions should give us cases per million. So case per million is going to be confirmed, populations per million. Let's run this, see if that makes sense. Again, don't worry about these warnings. It's just telling you that you're working with something that's pointing to an original data frame after the merges we did. Looks like we're getting a lot of nulls, so that's an issue. Afghanistan, this should have worked for Afghanistan, so let me make sure I didn't do anything wrong. Confirm divided by population millions. That should have definitely have worked. Let's try this again. Confirmed population millions, cases per million. Let me do a quick check. Let's do info to make sure they're both numeric. Country, they're both floats, so why does this not work? That's weird. That should have definitely worked. Might be an issue with the copy, but I don't think so. That shouldn't be an issue. They're all null. That doesn't make any sense. Oh, doy, because I said DF. Sorry. So many typos. It should be DF country. Okay, hopefully that makes sense to everybody. I accidentally typed DF, which was the original data frame, and not the original one. Hopefully you're getting a pretty realistic view of what it's like to. It also is a little hard to be constantly looking over to the stream and typing this at the same time. Cases per million should be equal to DF country confirmed divided by DF country population millions. DF country. There we go. Whew. Getting there, getting there. All right, deaths per million is the last one we need to do. We're going to say deaths per million is equal to DF country, and this will be deaths divided by DF country population millions. There we go. DF country. All right. Finally, we got a nice data set. So I want to show you something we can do for sorting. And I also want to show you this kind of cool thing that you can do with Jupyter, which is you can actually style the color of these data frame cells based off the value itself. So what I'm going to do here is I'm going to do kind of a sub-selection. So we'll say my DF subset is equal to DF country, and I'm just going to take a look at the following. I just want the country name, the confirmed cases, the population in millions, and then finally let's do cases per million. Make sure I don't do any typos as I'm trying to see this at the same time. So there's our DF subset. Let's go ahead and we can see that it looks like there's going to be some extreme cases, right? This mainly has to do with the fact that there's hardly anybody living here. So if they just get a couple of people, suddenly you're skyrocketing on cases per million. So keep that in mind. So we'll say DF subset, and then I can sort values by cases per million. And let's go ahead and do this. The reason we see some of these countries showing up is because basically they haven't confirmed anything. So it makes sense that some of these haven't confirmed. Puerto Rico, being part of the United States, is probably not reporting anything by themselves. So let's go ahead and say this is going to sort values ascending is equal to false, since I'm probably just interested in the ones with really high. Okay, so some of these make sense, right? Because the Vatican City, there's essentially almost nobody that lives there. It's just the church, right? So like if one person gets sick, suddenly you're going to be completely screwed. And for whatever reason, the population in millions is 0, which kind of makes sense. There's hardly anyone there. But for other ones, you can begin to see how it becomes an issue. We can also then begin to sort values based off just the number of confirmed cases. So you can see United States, India, Brazil, the ones you've seen on the news, right? And then you can also see the cases per million here. So I mentioned you can actually style these, which is kind of interesting. The way you do that is, let's go ahead and just grab the head of this. So let's see maybe the top 20 cases. So what's nice about this is I'm sorting based off confirmed, but then I can also do a comparison based off cases per million. So I can kind of fairly compare countries to each other, more or less. Basically, I can see while United States is technically doing the worst and India supposedly is doing the second worst as far as confirmed cases, clearly United States is much worse off because the cases per million is just, way, way worse. Although, as you're obviously aware, testing has a lot to do with this. So what we can try here is the following. Let's hope this works. Sometimes I have issues on my browser because of the various plugins I have. But you can say style, background gradient, and then choose a color mapping available to you from Matplotlib. So like reds is one of them. And then say subset is equal to cases per million. All right, let's see if this works. I'm going to zoom out one bit so you can see the whole thing. So essentially, there's this style parameter that's available in DataFrames that if you run it, you can actually color these cells. So now I know it's sorted based off the population, or excuse me, by confirmed, but I can clearly see who's doing worse and who's doing better based off the coloring itself. Any questions on that one? I see in the video you're not quite there yet, so I'll wait. I'm actually going to type it right now. Any questions on the coloring? Questions on coloring? I know it looks also a little blurry, but you can, hopefully that's kind of a cool thing you can check out. That way you can kind of visually see two things at once. All right, so what we're going to do now is maybe try to do a plot. I don't believe it works outside of Jupyter, Nathan. You can try it. I don't believe it does. You do have all the directions in the notebook. The notebook is way more organized than what I've been doing, but it also is kind of a slog to go through because it does everything at the top as if you're going to do everything. So this is kind of what we're going through. We kind of went through this cell bit by bit in the notebook in order to get this. And it also drops some countries later on. So you have all the proper full directions there that are available to you. So just a heads up there. It's all available to you in the notebook. So it should be a little nicer than watching me live stream, but hopefully the live stream helps you answer questions or just show you a realistic application of why it's hard to do this on the fly. Yes, you can color more than one column. I believe so. Okay. So what I want to do is I want to show you possibly one type of plot, and then we're kind of getting close to 2 hours, but you do have the notebook to kind of go along with it and see it. I think most people were able to. Did people install Plotly and Cufflinks and Folium? All right, so let's go ahead and do one. Let's do one visualization, and then we can kind of call it a day as we kind of reach 2 hours. So I don't keep everybody on this live stream forever. And you obviously have the code and for many more visualizations as well. And I do kind of want to show you one of these interactive ones. Let's pick one that's relatively simple. So what we can do here is we can take a look at one of the original data frames we've been working with and try plotting it out. So let's do the following. Okay, so let's try an iPlot. So let me look up. Sorry, I want to make sure I don't have a huge mistake again that I have to come back and fix. So let's plot the actual cases on an interactive chart with Plotly using cufflinks. So what I'm going to do is figure this out real quick. Sorry, I'm trying to find this in my other plots. dsconf. All right, so there are CSV files that are actually kind of already organized for you. So one of them is called time series COVID-19 confirmed. So if you notice, we actually have a lot of CSV files. A lot of these are cleaned. Maybe next time I'll just start off with a very clean data set so we don't need to do the cleaning ourselves. But there are the time series CSV files that are already cleaned and ready to go for us. So what we can do here is the following. Say df confirmed cases is equal to pd read CSV. And I'm going to open up time series confirmed here. And if we take a look at time series confirmed, you'll notice it should look something like this. This is the kind of cleaned data set that is worked with throughout a lot of the course. That essentially, it's a transposition or pivot of the biggest two data frames, and then we also attach latitude and longitude for the purposes of geographical plotting. So basically, you can check out the Folium parts in the notebook for plotting latitude and longitude. But what we can also do is really easily plot out an interactive time series as long as you did cufflinks. So what I'm going to do here is really quick edit this. So let's rename country region to just country. So we'll say DF conference confirmed rename columns is equal to, and we're going to say rename country region to country, and say in place is equal to true. So that just cleans that up a little bit. This is kind of the biggest data frame to work with. So if there's only one data frame you're going to work with in this entire notebook, just read in this one, confirmed cases. And we have the country, and what I kind of want to do is plot out day by day their charts, right? That nice time series there. So let's go ahead and do that, and then we'll see if we can do it not just with pandas, but also with Plotly and cufflinks. So it should look pretty nice. So what I'm going to do is I actually don't care about province, date, latitude, and longitude. So I'm going to drop those for now. So we're going to say drop or df confirmed is equal to df confirmed drop, and I'm going to drop the following columns: latitude, longitude, and province date. I also probably underestimated how large of a project this is. It's probably like a several-hour project that made too long for a live stream. So let's do this. We're going to say df confirmed. Whoops. Forgot to pass this in as axis is equal to 1. There we go. So now if I take a look at df confirmed, I have this really nice setup data frame that has the country, and then it has these dates. So what we can then do is if we take a look at this, I can do a group by on the country and then sort those values. So let's do the following. We're going to say df, or let's just make this into a time series. So I'm going to say time series of my countries is equal to df confirmed cases, group by the country column, and then take the sum. So now I say ts country, should look relatively the same. It's just going to slightly clean some stuff up. And then what we're also going to do is I'm only going to grab the countries with the most cases in the last state of the data frame. So there's I don't want to chart here with 188 lines. It's just too many lines to actually display. So let's just grab the big players that are quote unquote doing the worst as far as number of coronavirus cases. So we can do this by sorting the values. You can transpose, which we are going to do. So if you transpose this, it's going to look like this, this is actually what I'm going to end up plotting, but I do not want to plot 188 lines on the same plot. So what I'm going to do is just say ts country, and let's go ahead and say the original, I want to sort by this column right here, which is technically the last column, right? So I can do the following. I can say sort values by, and I want to sort it by the last column. So I'm going to say sort by 9, 16, 20. Ascending is equal to false. Check this out. Does this make sense? Yes, right? It makes sense that now US, India, Brazil, Russia, all the ones we've heard on the news that are not doing too hot. And then let's just grab, how about we grab the 10 quote unquote worst performing countries. I feel bad saying worst performing, but you get the idea of what we're trying to say. Okay, so let's go ahead and label this as my top 10 countries. So now I have top 10. It looks like this. However, typically what I want is this to actually be transposed so I can plot it, because I do want to plot the dates themselves, not the countries. So we're going to say transpose. Get something that looks like this. Whoop, transpose. There we go. And once you transpose this, if we do this correctly, we should be able to plot this. Let me just check to make sure this doesn't break. Okay, so this is kind of what I want, but if I say iPlot, and you installed cufflinks correctly, hopefully I installed it correctly on my end. Oh, I have not imported it yet, so let's say the following. Import cufflinks. And I need to also import Chart Studio, which means I need to say import. There's a couple things here what we need to do. If you installed cufflinks, you should be able to say import cufflinks, and then we also need to say, let's see, from Plotly offline, import iPlot, and init notebook mode. If this doesn't work, I know another way of doing this, kind of a workaround. And then we'll say cufflinks go offline. Essentially, Plotly, one of the issues with it is it keeps trying to connect to its online servers because it technically is a paid service. So you have to specifically specify it's like, oh, I don't want to connect with your servers, just do this all offline on my own local connection. Otherwise, it's trying to connect to your Plotly account. And then we'll also say init notebook mode connected is equal to true. So these are essentially the lines of code to make cufflinks work offline. Let me try running this again. There we go. And this is kind of what we've been wanting. Nice. So this allows you to essentially quickly make a plot interactive. Except you just have to remember, and all these import lines, they're at the very top of the notebook, of this storytelling notebook. It's right here. And there's some other Plotly stuff here that you actually don't need to worry about too much. It's mainly just these lines of code. Any questions on the imports? And any questions in general over what we just talked about? I cannot actually see how many concurrent viewers we have. I think it's only about the 30, so it's just like a small little class here. Any questions at all? All right, so I did promise you we would show you Folium, so I will try my best to quickly show you Folium. I know we're kind of getting a little long in the tooth with this presentation, but I hope it's obvious to you guys now that you should be able to call iPlot on a wide variety of any of these plots to plot kind of whatever you want as you go along with this. So now what I want to do is just kind of go through one of these kind of quickly using Folium, which should be able to line this up for us. But any questions before cufflinks? Just so I say this, cufflinks, auto connects, pandas plotting to Plotly interactive. You know, it's a good question. I might make this kind of a two-parter just because it was a huge notebook. We'll see. Maybe we grab a subset of the data set and not make this, because this notebook, if I were to run through it, is probably like a 6-hour notebook, which might have been a mistake to try to go through it in a single session. But I do want to show you this Folium mapping, and then we can kind of call it a day. And hopefully we've shown you enough that you can revisit this notebook yourself and be like, oh, very cool. I can do all these plots. And at a certain point, a lot of these plots end up being the same in regards to the code. It's just passing in a different set of data, right? So here you're passing in confirmed cases. Here you're passing in the number of deaths, which is just another CSV file we have set up for you. Here you're passing in time series since first victim, etc. A lot of these things are kind of the same. So what I want to do, and here's just like another analysis of the United States instead of the countries. And then it goes further into New York City. So we'll see if it makes sense to jump back into this data set. It was maybe it was too much to do, I think, in one stream. I saw like, oh, this is really cool. I'm just going to do the whole thing. And then obviously I messed up one time and holy crap, it went kind of haywire. But I think this is really cool, the Folium stuff. So I do want to show you that, and then we can end the stream. I thought the streams would maybe go like 1 hour, but I guess they're going more like 2 hours. But hopefully you guys don't mind. And they're all recorded and saved, so you can always check those out yourself. So let's check out these bubble charts. They are not the I would say they're not the best plot types for this sort of thing, because eventually it just looks like the all the cases in the world are in the United States, but it's just because of the ratio you use for the radius. That isn't to say the United States is doing poorly in this. Obviously, we are not doing that great. But just keep in mind, the ratios can be a little misleading on the plots. So let's kind of explore how to do a Folium mapping plot. Recall, you should have pip installed Folium in order for this to work. I think one way to just check if this is working for you is to just create a map object. So we'll say map1. Don't use just the word map. Map is a keyword within Python. So say map1 or whatever you want, or geomap. So I can say something like geomap is equal to Folium map dot map. And I think if you just run this, you should see a map pop up if you just call it geomap in the same cell. Let's see. I don't think you have to actually put anything on it to see the map. I want to check this out. Yeah, perfect. Okay, so go ahead and see if you were able to do this. And I think this should make it very clear just how powerful Folium is. The fact that, oh man, with one line of code, I suddenly have this huge interactive map of the world that I can add stuff onto. And that's really the whole idea behind Folium. You create this map, and then you just add stuff to it based off information you already have. And let me know if you have any questions on this map. Folium is this really cool library that you can check out. Okay, so what do I actually want to add to this? I would want to add stuff based off this data frame that we had earlier of this confirmed cases. So if I take a look at df confirmed here, notice I have these country columns. And essentially what I want to do is go back to where we had latitude and longitude. The one caveat for using Folium is it does use a latitude and longitude system, which means you will have to map or combine or merge your existing data frame with some latitude and longitude geographical information. If you recall, when we first read this in, right here, I dropped latitude, longitude, province, state. So let's read it in again. So now if I see df confirmed cases, I still have latitude and longitude. So what is it that I actually want here? I really just want latitude, longitude, and then the most recent column, right? Because that's kind of all I care about. So what I'm going to do is come back here. And let's check out, we'll say df is equal to df. And we're going to say the latitude column, the longitude column, and then the, what was the last date in this? I think it's September something. September 23rd, 2020. Okay, and this should be df confirmed cases. So we run that, and this should be, hopefully I didn't mess anything up, but this should be all the information we need. Yeah, so essentially what I'm going to do is I'm going to put a circle down for every single country here, latitude and longitude. And then what I can also do is let's actually grab, I shouldn't be resetting this. Let's actually grab the country name as well and the number, just so it's clear. Sorry about this. I'm going to read in this data one more time. So I should also keep the country region. So we'll come back here and let's also keep country region. That way I can add in it as a label as you hover over it. Please feel free to chat and ask questions as we go along here, just so I don't feel so alone as well. Okay, so we have country, latitude, longitude, and then the number of confirmed cases based off all of this. So what I want to do is just plot out some circles on Folium and then add them to my geographical mapping. And luckily for this, it's actually quite easy. So what do we do here? I'm going to kind of build this up as we go along with Folium. I have an empty map. That was obviously really easy to do, right? It was just, here's my map, ask for it, and here it is. So now what we're going to do is add circles to it. So I'm going to say for, let's say, index, or IND, in range 0 to the length of, what was Google using to show the map of the election? You know, for election mapping, I think they actually use paid services because of the counties. There should be something similar with Folium, but US county data I'm not sure if that's actually included with Folium or not, but you can check it out. Length of df confirmed. And what I'm going to say is folium dot circle. So folium has a bunch of things you can add in, and one of them is a circle. So we're going to say, okay, for every single row, right? So for every index in that df confirmed that we're working with, we're going to say folium circle, and then I'm going to say just create a circle and add it to geomap. But now the question is, where do I actually place this? So if you check out circle, it has a location and the radius, as well as a pop-up and tooltip, etc. So we should probably tell it where the location is on the map. So where's the location going to be for each circle? Well, we have the latitude and longitude, right? And so what we're doing is we're essentially going through every row in this particular data frame and saying, okay, at index 0, grab latitude at index 0, longitude at index 0, and then put a little circle there. So let's see if that works. We're going to say for the circle, and this is where we can start going multiple lines here. The location is equal to, and I'm going to say the location is equal to df confirmed cases, ILOC at the index, grab the latitude column, comma, df confirmed cases, ILOC at that particular index location, grab the longitude column. And hopefully this makes sense. So what it's doing is going to add a circle at every single latitude and longitude. And let's just run this to make sure it works. Oh, it requires the radius as well. Let's keep the radius as 1 or something. We're going to say comma radius is equal to, let's just put 1 here. Bingo. So now we put a little dot or a little circle at every country in the world that we have data for. Any questions on this one? All right. So I don't actually want my radius to be the same for every country. I want my radius to be based off this column value right here. So let's go ahead and do that. We'll say that the radius, I'm going to put this on a new line just so it's clear, is equal to df confirmed ILOC at that particular index location, and the column value is that date 9/23/20. Let's confirm that, make sure it works. Okay. Now keep in mind, if I just run this as such without actually editing this radius by some sort of multiplier, it's going to be distorted. I'm going to run this and hopefully this doesn't crash, but you should see a huge circle on the map, like just something absolutely ridiculous. Okay, it did crash. Object of interest is not JSON serial, so let's make sure we did this correctly. 923. Let's try multiplying it by a very small number. Times 0.01. All right, the radius is still maybe not big enough. Okay. So if we were just to say the raw data, it wouldn't work, right? Because it's saying, okay, the radius for Afghanistan is going to be 39,000 units. And we could see just how bad one dot was, or like a unit of 1, right? So it would be a circle that takes over the entire map. That doesn't make sense. So almost always, you're going to add some multiplier to your raw data. So what we're going to do here is, well, technically we're kind of almost done. We have to kind of choose a correct multiplier. Maybe 0.3 would be the right ratios to compare countries. This is more or less okay. I think it really shows you where the hotspots are, right? So you can see just by looking at the world, United States, Brazil, India, and Russia are kind of like the worst. Or maybe not the worst, but the countries with the most confirmed cases, right? So hopefully that should be clear from this. We can also then start to edit things like the color. So I can say color is equal to red. And essentially, we kind of start building out the maps you've seen maybe on the New York Times website, right? If you visit that website, they kind of make maps that look like this. You can also start saying things like, okay, fill is equal to true. And if you're wondering, how do I know these parameters? I don't. I just look them up in the documentation. And slowly but surely, you start getting these kind of nice map calls. And what you can also do is, instead of starting at this overall map view location, what you can do is say a starting position here. So I can say location is equal to some latitude and longitude to start at. So I can actually, every time I render this, force it to start at a particular location. So this is kind of really zoomed in on China. But as you zoom out, you'll see that it started in these latitude and longitudes. And if you want it to start at a certain zoom level, what you can also say is zoom start level, and choose something like 3 is probably a reasonable amount. So it's kind of showing you here. Something we didn't do in this particular case is like sum up certain regions, but hopefully you get the idea of what's happening here. And really, that's kind of the main point of this Folium capability, is you create the map and then you add stuff to the map. And you should now be able to easily expand on this by checking out the Folium documentation. Folium is just, it's really easy to use as far as like adding stuff, once you understand the main idea that you create a map, add stuff to the map, show the map. That's essentially, it's as simple as that. The hard part is figuring out this little loop and saying like, okay, how does this match up to what I'm showing? What we still haven't added yet is if I click on one of these dots, nothing really happens, right? So it would be nice if I hover over one of these dots, it actually tells me the number of deaths there. So how do we do this? Well, we simply add in a tooltip factor. So we say tooltip, and tooltip is essentially what it shows as you hover over something. So if I say tooltip is equal to info and run this, anytime I hover over any dot, it will show me info, right? And so what I actually want to do is have this change depending on each dot. So I should show maybe the country region and then the number of confirmed cases. So how do I actually do this? I'm going to say the following. I'm going to say tooltip is equal to, let's put this on a new line so it's easier to tell what's going on. I'm going to say tooltip is equal to country. And then we'll go ahead and say df confirmed. Oh, we have to add this in, whoops. I'm not really adding this, I'm concatenating it. So df confirmed. And then I want to label country region. However, I do need to specify based off the index, right? So I'm going to add in this ILC index, just as we did before. So let's check if that works. So now as I hover over it, I get to see the country, right? And you'll notice China is separated out by regions, which you could then kind of manipulate your data frame further. Okay, so hopefully it's pretty interesting. And let's add in as well the number of cases. And the way we can do that is by saying, this actually takes HTML code. So if you want a new line, you're going to have to say break, BR, as a string. So we're going to say break, and then let's add in number of cases here. So we'll say cases, and then add in df confirmed, and the number of cases is equal to this value right here. And we have to do ILOC again. ILOC at this particular index location. And then we'll ask for the confirmed case column. So again, all we're doing here is saying the country on hover, and then do an HTML line break in order to see number of cases on a new line. And the reason I can add these together is it's just concatenating it. So we run this. Oh, whoops. Looks like this is a number, not a string. So I'm just going to transform it to a string by passing it into str. That way, because I can't really add a string and number together. If I want to concatenate it, this should be a string. So we'll run this. And there we have it. And now you hover over this, and it'll show you the cases as well. Pretty cool. So obviously the main part of dealing with something like this with Folium is to figure out the logic of referring to a single row in a data frame, right? Because these are all just single values. That's the hard part. And given what we covered so far in this stream, you should now be able to look at that notebook and have a really good understanding of the changes that are occurring in each of those cells. So the actual notebook itself kind of repeats this for various pieces of data. There's also this kind of Plotly choropleth that we didn't get to, but you can possibly also do this with Folium as well. But you can see pretty much after that, it's kind of all the same thing. All right, and I think that's going to start concluding this stream. We're about to hit the 2-hour mark. Anybody have any questions in the last few minutes as we go about this? You can also check out Folium online and the documentations here. And Folium does have its own choropleth maps you can experiment with. You can see here. So if someone was asking about US election data, how it's plotted, you could kind of do it yourself. The main thing is where you're going to get the data from. So you'd have to then like do web scraping to go to the Secretary of State's data. And so you can see here, this is styling based off counties. So you can see, oh, I could start making my own website that could show like election results based off the counties themselves. Yep. So any questions before we end this stream? I'm going to wait a little bit to see you guys catch up as we finish this stream. Any questions before we complete stream? All right, I'm going to look at the chat real quick. Some nice conversation there, people helping to. Please tell me how to approach the AR will be suitable for scraping. I don't know how to scrape VK thing. I'm not sure what you mean by approach the AI part, unless you're, oh, for example, if input, oh, there was this question last time. I'm not sure what you're talking about. What do you mean input? You're kind of, you need to say way more context over what you're talking about. If my input is equal to football, it should return a list of users who have an interest in football. What? What are you talking about? In reference to what? What is your data set? I'm going to need way more information to give you an answer. I don't know what VK is. Should I Google search VK for the answer? Is the largest social European network. Oh, that's, oh, by Russian. Oh, interesting. We could do some election analysis, possibly. As far as the election analysis goes, I definitely didn't think it would only be announced a day before my stream on who was going to be our next president. That definitely took a lot longer than I thought it was going to. Possibly we'll do some political analysis. We'll see how it goes. Okay, please tell me how to approach. Okay, let's see. VK. So you are doing something based off a social network, and you're scraping some stuff. You're gonna have to give me way more details over what your like data actually looks like. Like, what does your data frame look like? What are your columns? What are your rows? So while I wait for that little reply on that, any other questions? We'll see how crazy it gets with the election data. Maybe it'll be cool to try to recreate the New York Times map, right? That'd be kind of interesting, in my opinion. And see, and then we can also, I think what's really cool about the election map and the mathematics behind it is you'll notice like certain states were called earlier, right? So it'd be interesting to see if we can create like a little calculator that can try to calculate at a certain point once it's too late for a candidate to catch up on that difference. For example, like Arizona, right? You saw Fox News called it the day of the election. Versus other networks waiting. So it might be interesting to see the mathematics of like, at what probability of victory do you give one candidate the state, right? Do you wait till 100% or do you do something like Arizona? It's like, oh, if Biden has like a 95%, we're just going to call it. So we'll see what happens next week. As far as the VK question, you got to give me way more info. So I can't really answer that now. You haven't described your data set at all. So I'm not sure what you want me to give you there for. Please give me way more information. Maybe next week you give me more info as you kind of get more ideas of your data. Looks like there are no more questions. Cool. So yeah, we'll see. Maybe we explore politics next week. Okie dokie. I think that's it. I'm going to sign off now. Thanks, everybody.